Hello friends, today we want to discuss about the disk structures in the mass storage system of operating system. Now, magnetic disk drives are addressed as one large dimensional array of logical blocks where the logical blocks is the smallest unit of transfer. The smallest addressable unit on a disk storage is a block. A logical block size is normally 512 bytes. It is possible that the block size may change with the formatting also. So what we consider over here in a disk structure is the smallest unit of logical. It is the logical block, that is the smallest unit of transfer. In the last video we have seen the smallest unit of addressable unit. The smallest addressable unit was the sector. But when we talk about the logical blocks or the logical addresses or the logical spaces, it is the block which we call as the smallest unit of transfer. So, the one dimensional array of logical block is mapped onto the sectors of the disk sequentially. Okay, so what is that? The blocks, the logical blocks are mapped to the sectors sequentially, that too sequentially. So it starts from the sector 0. That is, the sector 0 is the very first sector of the first track on the outermost cylinder. In the last video we have seen that the first track, the 0th track, is the outermost track on the platter. So sector 0 is the first sector of the first track on the outermost cylinder. Okay, the next is like mapping proceeds in order through that track, then the rest of the track is that cylinder, and then through the rest of the cylinders from outermost to the innermost. That means track by track to each of the cylinder, and through each of the cylinder it is moving from outermost to the innermost. That means the mapping will be done from the 0th sector in the 0th track to the last sector in the last track. That is from outermost to the innermost. Now, the rotational speed in here, to do the mapping, the disk must rotate. Okay, when the disk will rotate, the arms and the heads will do the mapping of all these things. So there are two ways to measure this speed, that is the constant angular velocity and the constant linear velocity. The rotational speed of the disk is, okay, in the constant angular velocity, the rotational speed of the disk is constant. To use the platter in an efficient way, the outer tracks which have the more sectors than the inner sectors are used in the hard disk. So the outer tracks are used in the hard disk for the constant angular velocity, and the constant linear velocity, the density of the bits per track is uniform. The density of bits per track means per track how many bits you are uploading or how many bits you are converting into the magnetic pulses. That is what is the linear velocity. To get the constant data rate, the rotation speed is increased as the head moves from the outer to the inner tracks. Okay, so like in the very first, in the angular velocity, the rotation of the disk is constant, but in the next constant linear velocity, the bits per rate is constant. You need to remember that. So next we come up to the disk attachment. In the disk attachment, okay, what is disk attachment? Disk storage is accessing. Now disk attachment is nothing but the accessing of the disk. Okay, and that can be done in two ways. The first one is the host attached storage, and another one is the network attached storage. Now, if I consider the host attached storage, this is accessed via the input-output ports. These input-output ports are available in several technologies like IDE or ATA, SC, SI, and fiber channels. So, the typical desktop PCs uses an input-output architecture called as IDA and the ATA. This architecture supports a maximum of 2 drives per input-output buses. Okay, it can support only 2 drives per input output buses. Now second we have is the SCSI. It is a bus architecture, and as physical medium is usually a ribbon cable having a large number of conductors. It is a ribbon cable having a large number of conductors. Now this supports a maximum of 16 devices. This supports a maximum of 16 devices on the buses. Now here the initiator is there, which will request the operation, and the targets will perform the task. Now each of the targets, it can have up to 8 logical units, that this can be attached to the device. Means 8 logical units are there. So 8 logical units which can have 16 devices to be attached. Next we have the fiber channels. In this fiber channels architecture, we can have, it is a high speed serial architecture. These high speed serial architecture, they can operate in two ways. First, it can be over an optical fiber, it can operate over an optical fiber, or it can operate over 4 conductor copper cables. Means like there are 4 conductor copper cables, there are 4 copper cables. Now it has two variants. First one is the storage area network, and next one is the arbitrated loop in the storage area network. Now this is a fabric. Here we can have 24-bit address space. Means here we can suppose 2 raised to power 24 address spaces, and which may host many storage units. And in the arbitrated loop, we can have 126 devices to be supported. So in this way, we have the host attached storage access. Next, we have the network attached storage access. This network attached storage access is a device, is a special purpose storage system. This it can access remotely over a data network. You can see the diagram. In that diagram, you have NAS with storage, network attached storages, which is connected to a network, that is a LAN or it may be a WAN, and that through that network it is connected to many clients. So we can have the access to the disk over a network. So two common protocols are the NFS and the CIFS. The clients can access NAS via a remote procedure call between the host and the storage we can have. And the NFS for Unix systems are the CIFS, and for the Windows we have the NFSs which we use it. And these remote procedure calls can be carried out over the TCP. That is these are the protocols, the TCP or the UDP over an IP network. This is what we are talking about, the LAN and WAN over here. This LAN and WAN over network over here can have the TCP or the UDP over there. And there is a new protocol, that is Internet SI protocol, which uses an IP network to carry out their CSI protocol. Next we have like benefits of the NAS. So NAS system stores data as files and support both CIFS and NFS protocol. CIFS for the Unix and the NFS is for protocol is for the Windows. The entry level of NAS systems are quite inexpensive. I mean, this can be carried out very inexpensively, and NAS appliances are connected to the Ethernet network, so again they are inexpensive. NAS devices may support one or more RAID levels to make sure that the individual disk failures do not result in loss of data. Now these RAIDs are what? These RAIDs are nothing but these are the array of the disks. Okay, these RAIDs are array of the disk, and they have certain technology. If one of the RAID fails, or one of the disk fails, the other can prevail. This happens. So there are, you can say, a copy of it. So in that way, NAS may support one or more RAID levels to make sure that individual disk failures do not result in the loss of data. Then next you have the storage area networks. These are how many left? So the storage area network, we continue in the next video. Thank you very much. That's all.